Chapter 2, Section 2, Surface Area, Master Level, Rearranging Formulas. So the first formula here is gives the surface area of a solid cylinder, 2 pi r squared plus 2 pi rh. R is the radius and h is the height. And it asks us to solve for h. What that means is just take this formula and rearrange it. So instead of having SA, or surface area, by itself, we're going to isolate h so that h is by itself. So notice how this term here has nothing to do with h, and it's being added to this one. So what I'm going to do is subtract 2 pi r squared from both sides, because what you do to one side you must do to the other. Okay, so that gives me here on the left surface area minus 2 pi r squared is equal to 2 pi rh, because that's what remains on the right. Okay, so to finish, to isolate h, well, it's being multiplied by 2 times pi times r. So the only way to undo that is to divide. So I'm going to divide both sides by 2 pi r. Okay. And make sure this line is extended underneath both of these terms, not just one. Okay, so what happens is the entire portion here, the 2 pi r's, they cancel. So I'll just swap sides. H, meaning the height of the cylinder, is equal to the surface area minus 2 pi times the radius squared, all divided by 2 pi r. Okay. So this is the same formula as written above here. It's just rearranged, and now h is solved for. So when would you use a formula like this? Well, if you already knew the surface area of the cylinder and you knew the radius, you could use this variation to find the height. So just an algebra exercise. Next, this is the formula for the surface area of a solid square pyramid. So you have the base squared plus 2 times b times the slant height. And we're asked to solve for s. So we want to isolate this letter right here. So what I'm going to do is I'm going to subtract off the b squared from both sides. So the left side becomes surface area minus b squared is equal to positive 2 times b times s. Okay, so to solve for s, it's quite simple. I just divide out both sides by twice b. And that cancels there. So my slant height of this pyramid, it's equal to the surface area, if I happen to know it, minus b squared, which is the area of the base, divided by 2b. Okay. So again, this formula is exactly the same as the one above. It's just rearranged, and s is the variable that is by itself. Next, we have the surface area of a cone, which is pi r squared plus pi rs. Pi r squared gives you the area of the flat bottom, and the pi rs, that gives you what's called the lateral surface area. It's the, well, the curved face, if you will. And we just want to solve for s. So this is pretty much exactly like the square pyramid. So I'm going to subtract off this pi r squared from both sides, because the pi r squared has nothing to do with s. So if we want to isolate it, we need to get rid of all the terms that have nothing to do with s. Oops, little typo. So pi r squared equals pi rs. And I think you can predict that I'm going to have to divide both sides by pi times r. And that's going to cancel. Well, because pi r over pi r is just 1. So the slant height of a cone is equal to the surface area minus pi r squared, all divided by pi r. Now you will not be given these formulas on any kind of equation sheet. So if you need to use a formula like this, you'd be expected to come up with it on your own. All right, let's solve for the radius of a sphere. Okay, if I am dealing with the surface area formula. So this one's actually, well, a little bit easier in that this formula only has one term on the right, whereas all the other ones so far have had two. So there's no subtraction necessary because this term here contains r, or specifically r squared. So I'm going to write it out again. So surface area of a sphere is 4 times pi times the radius squared. Now if I want to isolate r, well, I first off have to divide out the 4 pi. Okay. Unfortunately, I don't have r yet. I have r squared. And that is equal to the surface area divided by 4 pi. Okay. Well, if r squared is equal to the surface area divided by 4 pi, r itself must be the square root of this. So what I'm going to do is I'm going to effectively take the square root of both sides. Okay. So this is just going to give me the radius equal to, and I'm going to have the square root of this whole thing. So if you were to put this in your calculator, you take the surface area, divide it by, I'll fix that s, 4 pi, get your answer, and then you would take the square root of that result. Okay, so I'll put a box around it. Okay. All right, well, let's put some of these to use. Number 1, it says determine the height of a cylinder of radius 3.1 inches and a surface area of 96.2 inches squared. Okay, so we actually already have the formula we need. I believe that was the first one that we worked on, where we solved for the height, because the radius is given and the surface area is already given. So the height of a cylinder is the surface area minus 2 pi r squared, all divided by 2 pi r. Okay. Now before we use this formula, we just have to make sure that there's nothing special about this cylinder, that it's not hollow, or that we're supposed to ignore the top or just the bottom, but it doesn't say anything, okay, to that effect. This is just a typical solid cylinder, so we can use this formula. But now we can input the values that are given. So this is equal to, and the surface area is 96.2 inches squared minus 2 times pi, and I'll just use the pi button in my calculator, times the radius squared, and the radius is 3.1 inches. So I'll square that whole thing. And everything is going to be divided by 2 pi, again, times the radius. Okay, so all we have to do now is work this out in our calculator. And it's here that you have to be careful. What I mean by being careful in this case is, if you look at this huge mess that we have to work out on our calculator, well, there are a lot of operations going on. We have subtraction, there's multiplication, we have powers and division and some more multiplication. So if you're not careful in how you input all this into your calculator with order of operations, you're probably not going to get the right answer. Okay, so I have a giant fraction here. So what I want to do is work out this numerator. So I'm going to type 96.2 minus 2 times pi times 3.1, and then I'll hit the square button. And then I'm going to hit equals. Now in my calculator it says 35.818, etc. Okay, that's not my final answer, but that is the final answer of the numerator. So now I have to divide it by the denominator. And here's where you have to be extra careful. I'm going to hit divide. Okay. Now if I just type 2 times pi times 3.1, then I will get the wrong answer, because your calculator will divide it by 2, but then it'll actually multiply this entire thing by pi times 3.1. So we need to ensure that everything in the denominator, okay, is being divided into this answer up here, the 35.8. So what you can do when you hit divide, open a bracket. All scientific calculators should have a bracket. So hit your bracket and then type 2 times pi times 3.1 and then close your bracket. Okay, and then hit equals, and you should get 1.84 approximately. And of course this is a height, and the height would be measured in inches. Okay, so play around with your calculator until you can get this answer. Okay. Now I didn't do this with this problem, but I always encourage it if you can. Let's draw a little picture. Doesn't have to be perfect. Okay, so it's my cylinder, and the radius, okay, that's this distance here, was 3.1 inches. The height, well, that's what we were trying to figure out. Okay, so that's what h would have been. And the surface area of the whole thing, well, I can't exactly point to one part, so you could make note, if you want, that the surface area was 96.2 inches squared. So drawing pictures never hurts. There we go. Okay. Determine the length of a rectangular prism, so it's just a box, of width 5 meters and height 2 meters and a surface area of 69 meters squared. All right, so we know the width and the height. We just need to determine the length, and of course the surface area is given. So what I'm going to do is, I'll draw a picture. So I need to draw a box. Now I don't care if it's to scale here. Doesn't matter to me. Okay. So it's the length that we want. So I'll label the length as L. Okay. And the width, well, that was 5 meters. And the height was 2. This is definitely not to scale, but oh well. Right? And the surface area, meaning the total area of all 6 sides, is 69.0 square meters. Okay. So earlier I showed you that the formula for the surface area of a box is just the area of these 3 faces here, and then you just multiply them by 2, because of course there are 2 of each. So you'd get 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Now before, what I would do is I would just rearrange this formula and solve for L. The only problem with that is right now L actually appears twice in 2 different terms. Okay? And from basic algebra, you should recognize that these 2 terms are not like terms, because one of them contains a W, one of them contains an H. Now there is a way to rearrange this formula and get L by itself, but unfortunately that involves a process that is called factoring. That's what we would have to do. But unfortunately, that technique hasn't been covered in this course yet. So we're going to do it a different way. And I'm just going to substitute all of the numbers that I'm already given in this question and then solve for L. So the surface area was, I'm going to leave the units out this time because I know everything is meters. So surface area is 69.0 equals 2 times L. and I'm going to substitute the width, that's 5.0, okay, plus 2 times L times H, and H is 2, plus 2, I'm going to run out of room here, so I'll squeeze this in, 2 times W times H. So that is 5.0 times 2.0. Okay? So why on earth did I substitute in the numbers first? Well, because when you simplify it, I'll just split this up here. There we go. So I get 69 equals, well, 2 times L times 5. The order of multiplication doesn't matter, so 2 times 5, of course, is 10. So I can write this as 10L. This term, 2 times L times 2, combining the 2's gives me 4. So I have 4L. This term doesn't have any variables anymore, so 2 times 5 times 2, that's just 20. But notice now I have two like terms. Okay? And you should know that 10L plus 4L is 14L. So I'm going to subtract this 20 from both sides. So that's going to give me 49 equals 14L. And then finally, to solve for the length, I divide both sides by 14. And then of course they cancel. So I'll just put the L on that side, do a swap. 49 divided by 14, you get 3.5. Okay, everything was in meters. I didn't have to do any conversions, so I'll put these units back. This is meters. Okay, so the length of the rectangle must be 3.5 meters. Okay, what you can do to check to see that your answer is correct, go back to the original formula that I wrote up here and just evaluate it, but replace L with 3.5. So go 2 times, here, I'll check it right now, 2 times 3.5 times the width, which is 5, plus 2 times the length, which is 3.5, times the height, which is 2, plus 2 times 5 times 2, hit equals, and bingo, I get 69. So it just confirms that this is the correct answer. Number 3, if the surface area of a sphere is 1,200 centimeters squared, what is the radius? Okay. So surface area of a sphere, okay, and this formula would be given to you, okay, in this fashion, is equal to 4 times pi times the radius squared. But in this case, the surface area is already given. We need to work backwards and solve for r. Now earlier in the video, we did the algebra, and if you solve for r, you get the square root of the surface area divided by 4 times pi. Okay? So let's work this out. Okay, so the surface area is 1,200 centimeters squared, there, divided by 4 times pi. Okay, so now I just need to be careful how I put this in my calculator. So I'm going to type 1,200, and then I want to divide it by 4 times pi. Okay, but if you just hit divide and then type 4 times pi, what your calculator will do is it'll divide by 4, but then it'll actually multiply your result by pi, and we don't want that. We want everything on the bottom. We want everything being divided by 4 pi. So put in some brackets. So type 1,200 divided by, and open a bracket, and then type 4 times pi. Then close your bracket, and then you hit equals. And you should get the number 95.492. Okay, but that's still under this square root thing. This is actually approximate now. However, the long decimal I still have in my calculator display. I haven't hit clear. So all you need to do now is take the square root. Okay? If you hit depending on the model you have, if you hit the square root button, it might clear this number. But what you can do is type in answer. Okay, look on your calculator and see if you see the letters ANS. Again, it depends on the model you have. But your final answer should be about 9.77. This is a radius, and we are in centimeters. So here we go. So let's put R back here. Okay. And of course, you can verify to see that this answer is correct. Just put it back into the original formula. 4 times pi times this radius squared. And if all goes well, I should get 1200, and I do. So I know this is right. Okay. Number 4 says calculate the slant height of a cone of radius 3 centimeters and height 4 centimeters. And then it says determine the surface area of the cone. So actually number 4 has 2 questions. So before we do anything, let's draw a picture. I'm going to draw a cone. It's pretty ugly. That's really ugly, actually. And the radius is 3, so that's that distance. That is 3 centimeters. And we're told the height is 4 centimeters. Okay? Well, the height of a cone is this. Straight up and down. That is not the slant height. This forms a 90-degree angle. So I'll label that as 4 centimeters. The slant height is this, right here. Do that in red. That's the slant height. I'll label that as S. Okay. Well, you should be able to see that this inside I have a right triangle. So one side is 3, the other side is 4. This is the hypotenuse. I can use Pythagoras. So these are all in centimeters. So 3 squared plus 4 squared is equal to, I'll keep it in red, S squared. All right. So to solve for S, let's work out the left-hand side. 3 squared is 9. 4 squared is 16. So adding those together gives me 25. And that is equal to S squared. So S, so it's just some number. If I square it, I get 25. Well, there's only one number that would work. It would be the square root of 25. And you should know that because 25 is a perfect square. So the slant height is 5. And I'm going to put my units back in. These were all in centimeters. So that is 5 centimeters. All right. So that is the slant height of my cone. And I need that because it says determine the surface area of the cone. Okay. And this is the formula for the surface area of a cone, which would be given to you. It is pi r squared plus pi r s. This pi r squared, that is the bottom face, that's the circle. The pi r s, that is the curved face, the lateral face around the side. But we have all the information we need now. So this is pi times the radius squared, and the radius, of course, is still 3. So this is 3 centimeters squared plus pi times the radius again times the slant height that I just found. And there we go. So work this out. Pi times 3 squared plus pi times 3 times 5. And you should get approximately 75.4. And this is a surface area, so my units are centimeters squared. I'll put that in there. I'll put a box. And there we are.